Okay. We are doing it. Well, thanks for watching. Today, I am working on, I'm working on a programming language. It's not a very good language. This is a hobby project. It started as I had some pretty lofty goals, ideas for a language, and a couple years later, what it's turned into is just, I'm quite content just to build something very mediocre that has basic features and works reasonably well. And yeah, really what I found is I got a little bit bored with the language design aspect of the project and got really started to really enjoy the compiler development. So, I'm sort of meandering along, implementing things that seem interesting to me or that help me learn more about compiler development. So yeah, I think very much in the spirit of the projects on Just for Fun, no really.dev, and coincidentally, this is also my favorite quote about programming that you'll find on that site as well. So I think this project is that. This project is about learning, having fun. Yeah. I'm in the middle of it, a few years in here, and what I'm working on now is optional types. So a little bit inspired by Zig, and I would say Yacht, the way optionals are handled. A little bit of a background. I write Scala professionally for a living and have for many years. And well, in Scala we have options, right? And option in Scala is pretty interesting because it's implemented completely in userland, just as in ADT. It's a sum type with two branches, a sum SUM type with two branches. There's a branch with something in it, right? Parameterized by a type, and then there's a branch with nothing in it called none. And Scala is a really powerful expressive language, and coming out of academia, I think that you can tell that the goal was that everything would be implemented in userland, that the language would be powerful enough to be interesting. But I think in industry, we find that, there's a few things that we do all the time, and it's nice if the language just knows about them. And I think optionality is one of those things. So, we have in Rust that question mark, or in TypeScript, your optional chaining. In Zig, your if expressions with bindings, which is what the syntax I've copied here, where the language knows about optionals. And I think a language should know about optionals. In Scala as well, this sum is a class. It gets heap allocated. It has a lot of overhead, not just the overhead of some width, but it's, yeah. Check my notifications. All right. Yeah, it's a heap allocation every time, and maybe that will get jitted into something else, maybe not, you just don't really know, but it's kind of painful. It's like, yeah, I need optionality, but I hate paying for the cost of that abstraction. So I think optionals can be cheap, both syntactically and in terms of compute, like runtime costs. So this is a toy language. The performance, of course, doesn't matter, but it's an exercise, right? So, how am I implementing optionals? I wanted it to be efficient, so we have, let's edit our sample program here. This is my sample program written in Nextlang in the source language that I'm working on. And here we have an int optional. And the way that's represented in memory is an LLVM struct with an I1, a single bit, a Boolean field indicating presence or absence, and then whatever the type of the scalar that I'm storing is. So in this case, int in this language is an I64. The only int type available for simplicity is an I64. So we have a struct with two fields, which just side by side, right? No allocation happening, just a struct on the stack. So this can be 1 or 0, which indicates the presence or absence. So obviously in a real machine, this isn't going to be 65 bits. This is going to get padded out into something else. I even was playing around with similar programs in Zig, and I saw the Zig compiler was doing something like, not quite like that, but it was actually inserting like padding into the struct itself. But I barely understand alignment, just getting into some of this low-level stuff. And so this actually works, and just sort of expressing my direct intent in the LLVM is good enough for me. So this int optional is going to compile to that, and we may be able to open up. So this is a.nx, the source file, so I can open up a.nxll, which is the LLVM for this file, and you'll see optional. Yeah, so we have, it's an I1, I64. We are initializing it to fully 0. It doesn't really matter what's in this piece, as long as this sentinel 0, you should never look in here, but I think it gets fully 0 initialized here with this instruction. As you can see in the source program, we're assigning it to 1 later. So that's this the second struct. I think this is the codegen for the expression x equals 1. Yeah, and then we're storing that into, this is all really x equals 1. And then this is where we store our populated optional into our pointer indicating our stack pointer, indicating our stack allocated pointer, indicating the variable x, the local variable x. Obviously it doesn't do anything, so if I compiled this with optimizations on, we would just get this. But yeah, I've compiled this with optimizations off. Cargo run. Yeah, I have implemented some nice quality of life improvements, so I can turn off optimization right here, and I can also say I want to print the LLVM out. And I'm in the middle of a bug fix right now, so things aren't compiling. So maybe let's just jump right into the problem with my optionals right now. The problem with my optionals is in my LLVM codegen, and I was working on this last night, and I didn't solve the problem until I was laying in bed, and then I realized it. So I wrote this note to myself last night. Let's just read it here. So here I'm codegenning optionals that are represented as a struct. So not all of them. I'm trying to do the null pointer optimization for types that are pointers already and not have any extra space spent. So Zig does this, Rust does this as well. But for the struct-based ones, so it's not a pointer representation for this optional, which means it's a struct representation. So the optional get expression interexpr is not a pointer but a struct because it's in a variable x, which we call loaded value on when we fetch it, so we get a struct. The variable should be a pointer to a struct, so we get a pointer. I think structs and variables might just be broken, so this is my ravings last night trying to figure out why. When I compile this, I get a panic during codegen. Some code that really wanted a pointer value here got a struct value. And I actually know why. So let's just jump straight into it. I have a function called getLLVMType, which, given a type ID in my type system, gives me an LLVM type, the LLVM type that I should place there. Let's say this is an argument to a function. Well, what should the argument be for this type? Well, it should be this LLVM type, right? Sometimes I need to know more specifically. Often I need to know something a lot more specific about its type, but this function is used to generate sort of generic LLVM types, like say a function signature, where I need to sort of split out the LLVM type representations for a bunch of types in my compiler. So, and I was realizing that I'm returning the struct representation of my optionals here, but while that is the type of their struct representation, what I should be returning here is just is a, if you'll humor me, oh no, I need to fix this margin. I'm gonna pause the recording and fix this margin. Look, this is actually line wrapping. Like, why don't I get the width in distraction free mode? We'll figure it out. Okay, I turned off line wrap. That seemed to do it. Okay, we're back. And what's happening here is I actually need to just say this is going to be a pointer type. Because while the struct is represented as a struct, like we saw, the 1-bit and then the 64 bits, the way we talk about that value, like if we were to return that from a function or pass it to a function, the LLVM type we want is just pointer, PTR. And pointers don't have types in LLVM. You interpret it with a type when you load, so really it doesn't matter what pointer type I say here. I could actually just say, you know, I64 type dot pointer type, because it's the pointer in the bit code doesn't actually carry a type with it at all. But anyway, I think that's the fix that I thought of last night. Okay, so now we have code that's getting the pointer but expecting the struct. And I think that last time if I'm not mistaken, why don't I have my output from before? Anyway, so let's run this with a backtrace. I still think this is the correct representation, and now we just need to fix a bug we have elsewhere. So we're codegen x per enter, and we're codegen optional value line 549. Okay, so yes, so we get LLVM type, and then we expect that to be a struct type, which we're not actually allowed to do. This is for getting the generic type of something. In this case, since we need to codegen the struct, we actually need to know exactly what type of struct it is. So we actually don't need the generic type at all. We actually want this to be our specific method for building build optional type, which, as you can see, returns a struct type. It doesn't return a pointer type. And we'll just name this struct type. This is a really simple method. It just says, hey, what's the inner type? Is it one of the ones I use a struct for? Okay, make a struct with a bool and then the inner thing. Otherwise, if it's a string, just do string. We're going to do null pointers. And then if it's something else, I say I haven't gotten that far yet. So that's pretty much all we're doing here. This does not require a mute self, but I shouldn't have a mutable borrowed as self anyway. Already borrowed as immutable. Let's actually run this down. Immutable on 544. Okay. So this module is an RC to my typed AST. And because it's an RC, I can actually clone it Because Rust is Rust, I have to do this. Now I can module get type. And now I'm not borrowing from self, I'm borrowing from module, but I'm borrowing from module that I can borrow from as many times as I want because it's reference counted. So, you know, we pay for this at runtime just because annoying borrow checker, but I think that's the correct fix. We shouldn't really have a self borrow just to have this optional type. I could have also cloned this optional type. It's a tiny struct, and this also, this should not take mute self anyway. I wish, oh, get LVM type. Does this still insert into the map? Some of them insert into the map and some don't. So the idea is that this caches types. It's pretty frustrating that because we want to use a cache, now, you know, we need mutable access to the entire codegen struct rather than maybe just to this types map. So there's some techniques for avoiding this. I'll leave this as mutable now because I do have a number of fixed me's around this cache for types that I'm not really even using. So we'll revisit that later. Okay. Another found pointer value but expected the struct value variant. I think we're probably doing the same thing, and codegen optional has value. So optional has value. We take an optional and we basically want to codegen a Boolean. And we do the same thing. We expect this to be a struct, but it's not. It's a pointer to a struct. So okay, and we treat it as a value because we use extract value. So I could generate a load here, or load the pointer and then keep working this way. But rather than use build extract value, which in LLVM is an instruction that works on aggregate values, I'm going to use get element pointer instead. I think it's going to be a more efficient way to do this. So this is really struct pointer. I don't know why that had an underscore in front of it, by the way. So we still want discriminator value. So discriminator value is ultimately going to be the result of building a load, and we're going to say, I don't know what the type is, but this is going to be our discriminator pointer. And we'll call it discriminator value. That's fine. And the type is going to be this inner type. The discriminator is always an I1. I would like to express that in a more correct way than just hard coding I1 here again. So I'm going to have a pointer. We can go ahead and expect that to be a pointer. I don't have the LLVM type of my struct because I think previously yeah. So I could call my make optional type and build it and then ask it for the type of its first element. You know, I'm going to be doing a gep as well, which also requires the whole type. Well, let me just show you, get everything else in place, and then we'll answer our question. So this is discriminator pointer, and this is going to be a build struct gep. So get element pointer. Yeah. Thanks, Copilot. We do need a struct type. Struct pointer index 0. Let's just go with discrim pointer, and this can be discrim value. And then struct type. Yes, we'll call our helper. Build optional type. It wants an optional type and it looks at its inner, and that's exactly what we have. We have an optional type. By the way, an optional type, simply one, this is my entire type, so an optional, it simply holds a type ID to representing its inner type. That's all that's going on there. So, I could make it copy and treat it like it is. It's just a U32, but what if this grows a lot? I want to write the code such that I only need a borrowed, to the whole type and be clean. So that's why we have a reference here to such a tiny little struct. Some of them are richer and contain a lot more things, so I don't want to just be cloning them. Okay, but I digress. That's our struct type. We can remove our old solution. We need to abstract out which types. I actually do. I have abstracted that out. So is pointer repr, exactly. And it's been bothering me. If is pointer repr, this is struct repr. So really, I think it should be phrased as is struct repr. Else pointer repr. Just comment that. And at this point, we do need to match, actually, because I've only implemented strings. Made a mess of this. Okay, are we close? Yep, this is maybe not a fix me, but a to do. I'm not sure if is0 is going to return the right bit width. So let's pay attention to that once we run this. I have one less compiler error. Need to actually use struct type. Okay, geps can panic. Why can building an instruction that accesses a struct panic? I don't know. Thanks, LLVM. Okay, this isn't the same thing. This is just struct. There's one thing that's pretty normal that is unsafe. That's the one that really bothers me. I forget which one. It's not struct gep. Maybe it's just regular gep that's unsafe. We'll see. Okay. Does this want int values? It needs to be an int math type. Into int value. Oh no. Anyway. Ha. I've now made my code safe. All right. So how do we exercise this behavior? Cogent optional has value. I think that our program is going to cogent and optional has value instruction. Okay, we have another. Okay. So we got a struct on a struct pointer. It should be a struct pointer. Look at regular gap. I think we're let's look for other usages of build struct gap. So here's where I get the value, which is kind of similar to getting the discriminant. And struct type LVM. And I cogent expr. Expect it to be a pointer. Let's go to another struct gap for records. Yeah. And it's just a pointer to a struct. So let's print it out. Struct putter is, all right, I gotta get better at using DBG. DBG struct putter. Build optional type. It's going to give us our struct type. Well, struct type. Let's debug the type and the pointer. The pointer looks correct. So the pointer that it's the result of loading load PTR. It's what was in X, which should be a struct. And then struct type. Okay, so instead of casting this to an int value, let's debug discriminator value. And now discriminator value. Just to get it to compiler, to get it to compile. Okay. Discriminator value. we're loading the entire... Oh, okay. So what we're doing is we have a pointer to a struct, great. A pointer to a member of a struct. And now we want to load from it. And it's an I8. I mean, it's an I1. And we try to load from that pointer. But we try to load, like I said, pointers don't have types. You give them a type, a meaning of a type when you load from them. So even though we constructed everything correctly, when we load from this pointer, we're treating it as if it's a whole struct, which is bad. What we want is struct type dot get field type at index 0, because we store our discriminators in the first slot, and unwrap, because I know you're in there. And now we panic somewhere else. Okay. Still in, no, back in optional get. Okay, so let's hope that we fix that and go back to optional get line 646. And look, we're doing the same thing as last time, right? I mean, as the mistake I just made, here we're doing it correctly. So struct type, struct pointer, index 1 to get the value, and we're loading the type. Yeah, it's all good. Okay, it's the same mistake as before. Get LLVM type into struct type. If we want the struct type, optional type. Opt get. Oh no, where's my type? Optional type. I think we need to do our type lookup up here. Oh, let module, yeah. Are we gonna have, yeah, we're gonna have to do this. Okay. Let optional type equal module get type, opt get, result type. So that's not what we want. We actually want the type not of, so this is the result of get. So this is going to be the type of what's inside. We actually want the type of the inner expr, which is the optional. So that we can pass that optional type. But this thing expects an optional type. It doesn't actually need to, though. It could just take an inner type. And we're codegening an optional for that inner type. But again, what if optional type had more going on? We'd need all that information. So we'll leave it for now. And we successfully build. And my to-do, I wanted to know if our compare gave us an I1, which it does, as none is an I1. And then if it's true, we go to our consequent. Otherwise, we go. So in our consequent, I don't think I fully explained this. So the point of this program, so if X, which is an optional, then we provide a binding. And within this block, this scope, Y is of type int, not optional int, so we can freely use it. And the way we do this is we simply desugar this construct in the type checking phase. This desugars to if X dot has value, which actually isn't valid syntax. It's just an intrinsic. but eventually there will be a way to explicitly call this and get a Boolean. Then val y int equals x bang, like unwrap optional get, right? Really, you know, we make an optional get on x, and then your code below, right? So if we look in the generated code, we see exactly that. We see our optional value put on the stack. We see we're loading an I64 from opt value. So this is a pointer to the second field. So it's a pointer to this field of that struct. The 0 means the first one, in case this is a pointer to an array. It's not an array, so we say the first actual struct, and then I32 on the second member. Now we load as an I64 from there. We assign that to y, a local, sort of a stack local pointer. And now we call ret. No, okay. We call printint with opt value 2. Interestingly, we don't call printint with y. With like a loaded version of y, maybe it's just getting folded out. Anyway, that looks like it's working. So that's really exciting. Can I test it with a bool? I'll assert y in here. Let's start by trying to assert x. It's going to say assert takes a bool, not an optional bool. Assert expected bool but got bool. Excellent. So we assert y, and we're good. Let's assert not y. That should have asserted false. Oh, we dumped the LVM later. Maybe? No, exit code 0. Let's not print LVM. This is a debug error log I left in from before. Exit code 0. Assert not y. Assert false. Let's just make sure we haven't broken. Okay, assert failed, exit code 1. So we fail. X equal false. Okay, it doesn't really seem to matter. Let's take a look. So we have a discriminator and an actual Boolean. It's all null to start with. Okay, and we put x, we put that in x. Now we create a stack pointer for our true version, I1 true, I1 true. We put that in x. Our discriminator is we load from opt11 and It's none if that discriminator equals false. And if it is none, we go into if cons. If it is none, we go into the consequent. It's backwards. Else, print backwards. Backwards. If x. Oh, that's not going to reverse the condition. Okay. Is none. Is none. Optional has value. And we return if it is none. Not equal. Assert not y. Assert failed. Assert y. And we don't print backwards. I think our binding ifs are working. Let's see if we broke regular ifs. So what about inside of here? We say if x. Does Copilot know my language? X print true. I think I have a print bool. Prelude print bool. Well, let's print bool x, and then we'll also see if the nested if works. Expected bool, but got bool. Oh, see? That's the optional version. Now I should get the same on the if. Yes. This should be y. True. True. So the nested if works as well. Interestingly, I don't see two whole blocks. Now we should get true false, which we do. But why don't we have it? Oh, look, it generated a select instruction instead. That's so interesting. I need to look at this. So after we print the bool, let's simplify. And let's simplify even more. Okay. This is the same as before. And now inside of our consequent, I would expect to see some branching. We still have y. We store y, and now our code starts here. This is bool not, so if not y. We XOR y with itself, with true. And now stir 9, stir 11. Okay, because it's either stir 9 or stir 11, which are global constants. It looks like just a ternary. If bool not, then we pick this one, then otherwise we pick that one. So it's optimizing my phi with just a single value into this. That's so cool. I guess because neither branch does anything. Print optimize this. Okay, this time we codegenned an extra branch, 2 branches. Okay, couldn't optimize that way, but it still worked. And what if one of these didn't have an alternate? I'm just really stress testing my branching. Yes. And then if y, optimize this true. It's working. I think we can say. So how do I turn this into a test? We don't need to else print backwards. We can go back to assigning. I think that's a good test. X equals true. One of the things I have, right, it recommended this, is this auto boxing, right? It's perfectly safe. It's purely, look, you provided an expression of type t in a place where what was expected was an optional t. So the AST expression that gets generated here is actually not Boolean literal. It's optional sum of Boolean literal. So by the time we get to codegen, it's fully explicit. You know, it's done sort of at the syntax lifting level, which I think is nice. Yeah, we should be able to just assert y, and that should type check. Fix the indentation. Let's go maybe x. Maybe x is true. If maybe x, assert x. Should have done that a lot earlier. And I think we're pretty happy with that. So if we go to my optionals to do, I definitely have runtime repr for Boolean and for int. Let me just check unit real quick. Let's check char. Z. Assert x equals z. Yeah. And does it equal a? No, it doesn't. Okay, so we have char. I forget, I think it's unit. I don't have anything I can assert on unit though. Print x is unit. X is unit. Okay. What other types do I have? Okay, I haven't done array and record, but they're just pointers. Let's try string. I want to demonstrate. I did this already before this video, but I want to demonstrate that it. Well, let's get a nice type error. Expected optional, but got unwrapped value. Expected string, but got unit. Let's go with hello. I don't have string equality. So assert x dot length equals 5. I do have methods. Can I access field length on non-record type string? I said I had methods. So we need those parens. Boom! Codegen optional has value. Right, we're not completely done yet. But if I skip this, can we at least see the representation? Yeah, so this is an optional string, but this struct is how I represent strings, a length and a pointer. So if we were doing the optional thing, we would have a discriminant of 1 bit and then a struct i64 pointer. So this is correct, and we are storing null in there for none, and then once it's not none, we're storing a real string, and then we're returning 0. So I think that's going to work fine once we do it, and there is no additional cost to that null pointer optimization. So I think that's going to be a good place to call this this video. Looking at my to-do list, it's looks like we're really close. We're not entirely done with string, so I'll leave it here. Being done with optionals, I think we could maybe session optionals round 2. I think has value from userland currently only happens by desugaring. So someone could explicitly call that, right? I think that would be good. And we could do chaining. I think we test with optional array elements. That's going to be tricky. Make sure all that works. Really stress test codegen. Test with optional record fields. Yeah, I didn't even want to say it because it's probably not going to have bugs. Optional function args is actually pretty good too. So this is optional testing round. Has value from userland. Unwrap from userland. I think this can just be a prelude function, not intrinsic. Yeah. What are other features? So we can create optionals, we can set them none, we can ask if they have a value, we can match on them, matching with ifs. We don't have full-blown pattern matching, but that, I mean, this binding if is pattern matching. It does create a binding. It does add a variable to the scope. Desugars to a Boolean value in some way, which all matching is doing. So maybe matching is in the future. All right, well, thanks for tuning in. If you made it this far, I really, really appreciate it. I hope see you next time to finish implementing optionals and see, what might be next for this little language.